Good evening. My name is Aaron Harrington,
My name is Justin Turner.
I'm Bradley Flores.
And I'm Evan Olin.
and we are the Make Now All Stars. And we're here today to present to you our product for senior design. It's called the eFlyer Hub. Our customer is North Carolina A&T, and our advisor is Dr. Lee. Okay, introduction. So to begin, we would like to start with why we feel like our product is needed in the environment today. The current bulletin board process, or the way in which students find out about programs or events that are going on at the university or within the community as a whole, we believe is outdated. We believe there's room for improvement, and it starts with the current flyer approval process. In this process, a student must, one, print out the flyer, get it approved by the necessary people, and then after that, print off copies, post the copies around the school, then turn around and take them down, and it becomes unreliable. A lot of students don't even really check the bulletin board as much because a lot of flyers are outdated. We just want to be more aware of, be more eco-friendly and potentially save the university some money. The objective. Our purpose is to create a product in which students can digitally view and search posts going on, events going on around, and most importantly, make sure that it's a display that is, of course, visually appealing and interactive. We also want to make the product network accessible so that students can upload the flyers directly to the office, which will be approving it, and then, of course, make sure that students who are actually interacting with the board itself can use their fingers and things of that nature to make the process more appealing. Lastly, why do we do what we do? We do this to modernize getting information out to other students about different events and programs that are going on, because it is important that all of our students are unified and doing things together. So a quick overview of the presentation itself. We'll begin with the uses today, just electronic bulletin board as a whole. We'll continue with our objective breakdown, followed by the necessary requirements, and last, the conclusion.
Uses today. At University of Michigan, they use several touchscreens and throughout the Chrysler Center to bring more information about the team, have a very interactive environment that has done a very good job of engaging the audience as they go throughout the events of different sporting events. And then also, touchscreens as a whole are being used in day-to-day life, whether it's tablets, phones. It's popping up in dealerships even, where you can go in, start looking at the vehicle and interacting with this virtual environment to learn more. And that's what we want to do, is have our touchscreen engage students and give them the ability to learn more about what's going on campus. And as far as solar panels, we're thinking green. Everyone's thinking green. The Duke Energy and other municipalities are using solar farms to supplement their power production, and we are trying to supplement the power production and lower the power usage across campus.
Sorry about that. The next slide is our requirement specification page. Basically, we'll be going over our marketing requirements, how we can display the product in a way that will potentially allow it to be sold. The first is, of course, that it's user-friendly. We want to make sure that anybody from the ages of 5 to 25 to 50 can use the product. Next, we would like it to be energy efficient. We'd like to access solar power and make sure that it's not dependable on any one avenue of resource or energy. Last, of course, we want to make sure that we use a high-quality resolution for the screen. Make sure that, like I said before, it's visually appealing. And the last, we would like our product to be mobile. Potentially allow us to put the product in front of the program or event that's going on itself. And just display it like a sign to a door.
Okay, so this is a representation of our board and the inputs and output signals that it will handle. So what our system is supposed to do is to get data, flyer data from a student organization, and process it so that it can eventually be displayed for any student or faculty so that they can know what's going on campus. So what we have going into our system are flyers that are uploaded from the student organization, and those may need to be approved, so they're sent out as flyer requests, and that will go to the Office of Student Affairs, and they will approve it and be able to send the approved flyers. And the approved flyers will be recognized by the system, and they will be displayed on the visual display. The other parts of the project that the signals that will be handled are the touch controls, which is so that you can look at different flyers that are being displayed and different events that are happening. And the power that will be inputted into our system is both solar power and a 120 volt analog power that we normally have when we plug into a wall. So a peek into the system. This is how we are planning to handle all of these user interactions. So when the flyers come in, our main flyer data control center is going to process all of that data, and it will send the approved flyers out to the touchscreen display, and from the touchscreen display, touch controls will show which flyers are up, and you can also see any other information that we think is important to display. The network interface is so that we can connect to the network on campus and send the flyer data to be approved from this OSA, and it can also receive flyer data from approved flyer data or flyer data that's sent to be approved. Yes, so the touchscreen display will output our visual display, including all the flyers and different events that will be handled. The power supply will power each of the parts with an input of the wall and the solar power, and that will make a decision on how it's going to charge its supply and then supply the power to the rest of the system. So we're going to look into that part and see how we plan to supply the power to the other parts of the system.
This is the internals of the power supply, which you have solar light and wall outlet 120 AC voltage going into our power supply. The wall outlet power is going to an AC-DC transformer that will convert it to a 24 volt DC power going to the voltage comparator. Also going into the voltage comparator is a variable DC voltage coming from the solar panel. The solar panel will take the ambient light, whether it's from indoor or outdoor lighting, and convert it to that DC power. The voltage comparator will then take whichever voltage is better and send the power to the DC charger. The DC charger is going to charge the battery, and then the battery is going to power a power inverter, which powers the rest of the system. Previously, it was many items were in one block in our previous level 2 diagram. The voltage comparator, the DC charger, and the power inverter have been identified, and this is the route we are going in with the power supply.
So here we have our UML diagram that basically represents how our board works overall. So we have our network, we have the student organizations, student affairs, as well as the student themselves. So for our network, everybody basically interacts with the network, but the student affairs has probably the most control, which is what we want to have, because they're able to remove flyers if they want to, and they're able to archive folders for their own records, as well as upload the flyers via USB or via our network. So the student organizations, they're able to go to student affairs and upload their flyer and send the flyers to student affairs so student affairs can approve or unapprove the flyers, and they can upload those flyers either through the network or USB if they don't want to go to student affairs directly. And we have our student right here where they'll be able to download the flyers for their own personal purposes. If they see a flyer that they want to have, we're looking into ways whether we want to have it Bluetooth, sending it Bluetooth, or sending it by email.
This is the test document for the SemiFlux 5-watt solar panel. We have one that we were able to test with, and we wanted to use it to see what we could get out of it with indoor lighting alone. We know that the power is going to be great if it was outdoors, but indoors is where we were concerned. So we took the solar panel, found a dim spot here in Cherry Hall, and tested the voltage. We got approximately 6.6 volts DC, and we noticed that there was a LED circuit attached to the solar panel. Taking that out of the circuit, we were able to get roughly 12.3 volts in the dim hallway, which is more than half of what we need to charge the battery, showing that with 2 solar panels in series, we'll be able to charge the battery on hallway light alone.
So here we have our Gantt chart, which is basically showing the steps that we've been going through this semester. So even though we've had a couple roadblocks and we've been delayed on a couple things that we wanted to do, we're still close to being on schedule. So right here is where we're at, and that's around screen testing. So we should be putting in our request form for our screen, and well, we'll be putting in a request form for our screen to make sure it interacts with our Pi board that we have. But we have already hooked the Pi board up with a touch screen, and it's shown that it's been able to connect and be able to be used. So we just want to make sure that the screen that we're getting connects with it as well. And also here is our cost summary table. Right now we are still under budget for everything that we've put into order for. So we're at $318. So that just goes to show you that so far our project is still under the $500. It's very cost efficient, and it is going to cost next to nothing to be implemented around campus. So we have even with our touchscreen came out to be one of the most expensive things, and right now we're still under budget for everything that we're doing. So once again, we have our battery, our Pi board, the solar panel, the voltage comparators, the DC charger. So we have a lot of things that we're putting in an order for, and we're still under budget.
Okay, so for conclusion, before I continue, I would like to one more correction. The final product price is $382, close to $400. So moving forward, basically we want to just innovate the way in which students interact with programs and events that are going on. We want to change how the information is displayed and increase the engagement. We just see the growing demand in the market, especially in technological era. And more importantly, we believe we can make a product that's user-friendly, easily accessible, great resolution, and of course, energy efficient. Lastly, we went through our necessary requirements, our system design, our test plan, Gantt chart, followed by our cost breakdown. And this is our product. We hope that you one day are interested in buying it. Thank you.
Thank you. Now, questions from our advisor, Dr. Lee.
Yeah, can you go to that first level 2 diagram?
The level 2?
Level 2.
Well, wait,
Or the level 1.
I guess that one.
Yes.
Okay, so on the left are all the inputs, right?
Yes.
Correct.
And on the right, the output. So I know the visual display of the flyers, but what are you planning for that flyer request data, how is that gonna be on the screen and who has access to it?
Well,
So-
that's not gonna be on the screen itself.
Okay.
The data is gonna go to the OSA, but it has to leave our system for them to approve it. So that's why it's shown as a separate thing from the visual display. So no one ever sees what's going to be approved or what needs to be approved,
Oh,
except for OSA.
Yeah, that's under the hood.
Got you, okay, but can you go to one of those to actually do the request? I mean, like, can you go to one of the screens and actually, submit a flyer to that office, or do you have to use some other way to submit a flyer for approval?
Well, we want to. That is the
we
goal,
want
so
it to-
that we can have it set up so that they can submit it from our system. They can submit their flyer, and that flyer will be sent out to the OSA.
And if OSA approves or unapproves, it won't stay on the board, basically.
Right.
So it can be a medium that way. Yes, that's what we want.
It doesn't upload to the board. If a student organization uploads their flyer, it'll be sent to OSA because it's not approved. If it's approved, the control center will know that it's approved, and then it will send it to the visual display, which is output.
Yeah, so I guess what my whole question was,
Yeah.
when they go to submit a flyer for approval, they can actually use the
Yes.
Screen itself.
They should
Yes,
be
sir.
able to use the
Okay. I had another question about the solar panel. You're saying you disconnected the LED?
Yes, there's an LED that was in parallel with the positive, negative lines. So
Okay.
took that out of the circuit, and it was a big drain on the power apparently.
The LED was a indicator that the solar panel was receiving power.
Yes.
Was receiving.
Receiving power.
So
It was
light.
it was
light.
producing power. The LED came on. It's just a simple LED and resistor in parallel with the circuit.
It's not really necessary.
It's not.
Alright,
Yeah, we can measure if there was any issues.
okay. Yeah.
There's also been people making comments to saying that they were getting better power. Comments as far as like Amazon or whatever, the customer comments, reviews, saying if they
Yeah.
remove that, they got better results.
Right, and I guess especially in dim lit situations,
Correct.
maybe it wasn't as important outside somewhere,
Right.
you know, yeah, okay. Well, it seems like y'all got a handle on it, thank you.
All right.
Thank you.
Thank you.